continuously monitor the status of the weather as you are flying also. A knowledge of meteorology will at least enable the aviator to anticipate some of the difficulty which weather may cause. All of a sudden there could be a rain, all of a sudden there could be a gust of wind, all of a sudden there could be a storm, all of a sudden you could lose the visibility of your drone. Then all the things would be there. So you need to be prepared for such kind of scenarios. Okay. So this is what I was talking about. METAR. METAR is nothing but meteorological aerodrome report. So this gives us the required data such as wind direction, wind speed, etc. are needed for the safe flight. The drone operation will need to cross-check the METAR for safe and secure operation where we don't risk the drone. Okay, so that's why we have to see if you're flying. Let's say if I'm flying in Mumbai, example, I'm just taking an example. If you're flying in Mumbai, we are authorized to fly. So I will always check what is the METAR report of Mumbai airport or Mumbai aerodrome. So what does METAR gives us? It gives us several. There are a lot of other applications. There are a lot of applications available now on mobile also, like which will give you the forecast, good to fly, drone cast. These are some of the applications which are available. Drone buddy is there, air data AV or Windy. Windy is mostly used by the aviation people. Okay, windy.com, you will able to get almost all the information of your location. You can download that app in your mobile and you can follow the windy to check the status of particular location. It will give you the forecast for next 2 days or a week's time also. Like 7 days, it will forecast how the weather is going. Not not really could be accurate, but at least it will give you an option like how the weather could be because they have a data. They have a old data of last, let's say, 5 years, 10 years, 10, 20 years, 25 years. Based on that, they will predict how could be the weather at that particular time based on the scenarios. So there is a lot of algorithm has been written into these applications and the data what it is processed in the backend. It will help you to predict. Like if you see today is sunny, tomorrow it could be a cloudy. Based on the movement of the clouds, movement of the air pressure and temperature in the oceans, all that things help them to forecast the type of weather what we could anticipate in next 24 hours to 48 hours, or maybe over the period of a week also. So international standard. We talked yesterday about the standards what we use. So international standard atmosphere (ISA), static atmospheric model, how the pressure, temperature, density, and viscosity of the Earth atmosphere changes over a wide range of altitude and elevation. So whatever, like for example, if you see, as I'm staying in Bombay, the kind of weather what we see, and if even we travel 100 kilometers from Bombay, let's say we go to Lonavala, place like a Lonavala, the temperature, the because of altitude, because of the elevation, the temperature will that place will be much more cooler compared to the weather what we feel in Mumbai because Mumbai is closer to the sea. We will have a lot of humidity. That will always have a hot temperature over here. Whereas we go to Lonavala, it is altitude of almost like 500 meters. So that place you will always feel cooler because it's above the ground level or above the sea level. So difference will be definitely there. So as you move again, you further go to Pune, you might feel hot because that is a plateau. But again, you further go to a different location, maybe you go to Satara or someplace where you might feel cool. Depending upon the surrounding area, the way the terrain is there, way the grass and the trees are there, it will change. Like if you go to Mahabaleshwar, again that place will be very cool compared to Lonavala. That place will be much cooler than that because it's a hill station. Okay, it's a hill station at almost of 1,200 meters above the sea level. So it is established to provide a common reference for temperature and pressure and consists of table of values at various altitudes plus some formulas by which those values were derived. Okay, so let's see that. So what is ICAO published standard for atmosphere is MSL temperature is plus minus 15 degrees Celsius. MSL per that means these are at mean sea level. So mean sea level temperature is 15 degrees Celsius. So if you measure the temperature at the sea level, the standard is 15 degrees. What would be the pressure at that MSL? It is 1013.25 hectopascal. Okay, what would be the density? 1225 grams per cubic meter. What would be the viscosity of the lapse rate? Will be 1 point, or roughly you can see 2 degree per thousand feet. So as you climb 1000 feet, there will be a difference of 2 degree. Like if you are measuring 15 degree at 1000, it will be less. Okay, it would be somewhere around 12 degree, like that. So
Is it a standard?
yeah, these are international standards. Roughly 2 degree will be difference. 2 degree difference would be there. Okay. Then practically we use lapse rates here. I said 2 degree. Good for calculation for trophopause. So when we are moving in trophopause, every 1000 feet there will be difference of roughly around 2 degree. Roughly around 2 degree.
So at the sea level, it will be 15 degrees Celsius.
So as we climb, it is cooler. As we go out and out, up and up. So that's why when we climb Everest, what is happening? The density is becoming very low. You have to carry your oxygen cylinders. It will be very cold, so you have to have proper protections. We are on the same earth, but as we climb, it is cooler. The temperature is dropping as we go on higher and higher altitude. Now, type of pressure. Yesterday we discussed in aviation community the term QNE, QNH, and QFE are used to describe standard pressure, local altimeter, and field elevation respectively. So QFE is nothing but field elevation, means height from the land. Right? Yesterday we talked about QFE. QFE is the altimeter pressure taken at the takeoff location, which indicates the height. QNH is nautical height. QNH is the altimeter pressure taken setting at the takeoff location reduced to MSL, okay, mean sea level, under ISA condition, which indicates the altitude. Whereas QNE is the altimeter pressure setting at the standard atmospheric pressure, that is 10 to 1013 dot 25 hectopascal, which indicates the flight level. Okay, we'll see the next picture to give us the more clarity. Okay, so we were talking about yesterday this picture. So QNH is from the mean sea level, but whereas we have standardized the flight level, we always, because see, sea level will be different, right? Every time, every location, the sea level there would be different. Like where we have a high tide, the sea level will be different. Where we have a low tide, the sea level will be different. Okay, but what is the standard pressure at the standard location? The QNE will be the base, which will give me the flight level with respect to the sea level. But if I am flying the aeroplane on the land, definitely there will be elevation with respect to the sea level. So that elevation difference is there. So that difference will be minus, and this is called height. At what height I am flying. So when I am giving my position, I will talk with respect to QFE or QNE. Okay. Whereas when I'm measuring with respect to the sea level, I will talk about QNH. So I will say with respect to QNE, this is my flight level. When I'm respect to QFE, this is my height of the aeroplane. That's how I will communicate to the ATC tower. So they know where, with respect to what I am talking about, because they the ATC will always be following QFE because they are always on the land. There is no ATC tower in the sea or anything. They will be always having the ATC towers somewhere near the airport into the land area. So they will know what is the QFE of that particular location. Okay, with respect to that location. So they will always say, okay, now you are at 10,000 feet or 20,000 feet. So you have to correct with respect to QFE when you are approaching landing or you are going to take off with respect to that. So they will tell you, if you're going to take off, you climb and you go up to 10,000 feet and then report. Okay, so based on, after that you reach out to 10,000 feet. Accordingly, they will see the situation, and then they will tell you whether you have to climb or you have to go down by 5,000 or 2,000 or 3,000, or you may ask them to, you can now safely climb to 30,000 feet, kind of thing. So based on the situation, they will tell you, and then they will proceed further, ask you to proceed further, or they will tell you to proceed or connect. Let's say you are going to Delhi, so from Mumbai they will ask you to connect to Surat ATC, or they will ask you to connect to Ahmedabad ATC, and subsequently Jaipur ATC, and then move to Delhi ATC, kind of thing. So that's how you keep on reporting and keep on updating the ATC about your position and about your height at what you are flying. So that every time if there is some change or this thing, they will correct. Like whatever you are reporting based on your instrument, but their radar is also measuring your altitude and things, so they will see. So if there is any discrepancy in that, they will communicate to you. They will ask you to cross validate again. So you will always see your both altimeters. If your both altimeters are also showing proper, you will see your third altimeter also. Okay, and then there are other options also to validate things as you are flying your aeroplane. Okay, so this is just to make sure that you are following the safety protocols, you are following the proper instructions, the communication is happening properly, and accordingly you are taking your controls or necessary changes required for your safe flight. Okay. As of now, from a drone perspective, since we are not flying the drones on the sea or anything, we are flying the drones on the land. So for us, from the drone perspective, what we are important is QFE, the height of a drone with respect to that particular ground. So I will tell you like whether you fly your drone to 10 meters, 7 meters, 9 meters, whatever it is, or 12 meters. Because see, when you are flying a drone, ideal, let's say it is just a 10 feet away from you and you take off the drone. So 7 meters or let's say 10 meters also is okay because you are able to comfortably see the drone. But as he goes forward, let's say you pitch forward. So what happens, as it is going forward, you will see that drone is going forward, but you will, when for from your perspective, you will see drone is coming down because it is going further, so it is going down. So you will have that illusion. You will assume that as you are doing pitch forward, your drone is going down. Okay, that point time, what you will try to give throttle. You are actually flying the drone at 10 meters only, but because of the angle at what you are seeing the drone as it going forward, you will see the drone is going down, so your perspective will change, and your mind will think that you need to correct it. So as you are giving pitch forward, automatically your left hand, the throttle will also throttle. You will start giving throttle unintentionally without knowing yourself. So this is where the human performance would come into picture, and that is the reason why on the remote you have that altitude bearing over the setup. So you will see, okay, you will monitor whether it is 10 meters, yes, 10 meters. So you don't need to touch your throttle. You just have to do pitch forward. But because of your visual conditions, your seeing conditions, you are away. So imagine from 10 meters, you go to 500 meters. Okay, see how far the drone would be, and from your perspective, you will feel that it is very close to the ground. You go further, more. You will assume that your drone is almost touching the ground. As you reach 100, as you reach 1000 meters also. 1000 meter is almost like 1 kilometer away your drone. Okay, it's very difficult to visualize such a small drone at 1000 meters. Okay, it will be very difficult in a good day condition also, because drones are very small compared to what we see. If you see aeroplane, when we see the aeroplane flying in the sky, it looks so small, but still it is such a huge body. But when it is in the air, it is so small for us. So imagine how drone will be difficult even at 1000 meters. Okay, that's why we are flying the drone in visual line of sight as of now. So will fly the drone within 1000 meters, not more than that. Okay, beyond 1000 meters, it's very difficult to understand. Even you will not know what would be the heading of that particular drone. So limit yourself within the 500 meters. Even 500 meters is very high or a very long. Okay. For example, our the area field of area length and width is 60 meters only. So even it is not 100 meters. Okay. Even at 60 meters land, when you are flying a drone and the drone is very far at edge of the boundary also, it is very small. It looks very small. You will not able to make out the heading. You will not make out the directions, and that's why those strobe lights or the way the drone is manufactured, the shape, you will come to know the direction and all the things. That's how the drones have been designed. But like for example, you take the example of phantom drone. Phantom drone is very uniform from all the sides. It looks almost identical from whichever side you see it. So it's very difficult to make out the direction of the drone. So sometimes they just, that's why they color the side of the front side of the drone with red color, or they put some uh, tapes so that you make out the front side of the drone, or they put up the strobe lights so that you are able to make out the direction of your drone when you are flying them. or you use your instrument, that is your remote control, to see the position of your drone, heading of the drone, then what altitude it is flying, and all that parameters on your remote itself. Okay. So any question on the pressure, QFE, QNE, QNH? I hope you have
हा म्हणजे ऑलमोस्ट आलंय लक्षात.
So QFE is what we need to keep it. As from a drone perspective, you have to understand what is QFE or the height. Okay.
Yeah,
QFE म्हणजे सॉरी कंटिन्यू कंटिन्यू जगन.
Respect to the ground, what is the height of your drone? QFE.
like how a drone, I mean, when we are flying a drone,
Hmm.
so in my drone, I can see the height of the drone is flying.
Yeah. Let's
So
say
how it
example
is,
10 meter.
I mean, how
Let's
it
say
is measured?
so from the ground, from wherever the ground is there, that is your zero.
Okay.
From zero to whatever the height it is flying, that meter, that height it will define.
So
10 meter. 10 meter from your current position of the ground.
in that case, it will take RCs and the drone's distance.
RC? What is RC?
Control.
रिमोट कंट्रोल.
Control. Okay, remote control. Yes. So when it is on the ground before the takeoff, it knows it is zero. When you
Okay.
arm the drone, it
Okay.
will know that it is not takeoff. It is still at the ground. Okay, so that will take when it is at the launch station.
Okay.
It will have that position recorded as 0 degree. So as you give throttle, it will start measuring. So it will, let's say, 1 meter, 2 meter. So from the ground it will start measuring. So it knows the what was the base location. From there it will start and give you the input. Like now it is at 10 meter, 20 meter, or 5 meters, whatever it is. It would tell you.
So it is respective to the takeoff area
Particular
where
ground.
we.
Yes.
Okay.
That's why the when you are on the land, there is a difference. No? That height it is measuring with respect to the ground. You see the picture, right? The arrow is pointing here. Okay, so
Mm-hmm.
when it is at ground, so same the QFE, like if you see the definition, okay, QFE, what is it saying? Is the altimeter pressure setting at the takeoff location, which indicates height.
Right.
When you are before you are taking the setting, pressure taking, like before the takeoff, when you are on the runway, QFE will take the reading. That will be the your base reading, and as you climb, that time whatever the height is there, that height is taken.
Okay.
That is what we call as field elevation. QFE. Remember this last two words. FE. Field. Field means land. Field elevation. Elevation means height. Field elevation. Okay. N is nautical height. NH and nautical elevation. Okay. So this QNE. See, if you see QNE, QNE is with respect to the standard pressure. Okay. Because your sea level is different at different location. So a lot of time there could be confusion because the ATC may not know that point in time in a sea whether it is a high tide or a low tide. So if you give with respective, he will not have an accurate altitude. Okay, with respect to the, let's say there is a low tide, there might be a difference in, there might be a difference of 2 meters. Okay, so that 2 meter will add on to your altitude, or 2 meter will be reduced to your altitude. If you want to give a standard, so when you are flying, you normally give the flight level. Your flight level with when you say flight level, even when you see the word flight level, automatically the ATC will know that you are talking with respect to the standard pressure. That is QNE. When we say I am at 10,000 feet of height, so he will know that you are talking with respect to QFE. Okay, so that's why you see there are, see they would have told, like here also they could have used altitude, here also they could have used altitude, here also they could have used altitude. Okay, because at the end of the day you are talking about the height only, or they could have used the same words, height. Here also they could have used height. Here also they could have used I'm at height of so level, I'm at height of so level. But then it will not give you the corresponding result. So when you are talking with respect to the land, you are saying you are at so and so height. When you are talking about the standard pressure, you will say I am at a so and so flight level. When you are talking with respect to the mean sea level, you will say I am at so and so altitude. So when you use these words, terminology, okay, they will know what perspective you are talking about. When I am saying I am so and so height, The ATC will know that you are talking with respect to QFE. When you are talking, you are giving a distance with respect to the flight level. The ATC will know that you are talking with respect to QNE. If you talk
when
about,
we are when we are flying in any commercial flights, sometimes pilots used to interact with us, right? They used to say we are
yes,
flying,
yeah,
yeah, we are flying in the altitude of 30,000 feet, something like that.
correct, correct. So it depends upon where he is flying. So if he's saying, when he's saying we are flying at altitude of 30,000 flight, so that point in time we may be flying over the sea.
Okay,
So
okay,
maximum time, the safest path is always to fly over the sea, because
okay,
if something happens, you can safely land the plane on the sea. It's
okay,
always safer to land the plane on the sea, okay, rather on the ground, because ground will be uneven. We do not know how it will impact and all the things. So it is always safely to land the airplane on the sea or on water body. Okay, so that's why they will always talk we are flying at 30,000 feet. But if you are flying on a ground or something like that, they may talk about height also. But again, if he is flying on the ground and he is talking about altitude, so with the respective, so this height plus this elevation, okay, of that, he is talking about that altitude.
okay, okay.
So
Even
sometimes,
if he
for
says
example, you are going to Delhi, you are going to Delhi. So once you cross Ahmedabad, everywhere is land only. So at that point in time, even he is cruising at 30,000 feet altitude, he is saying, so he is taking account of this elevation also of that particular location. So he might take that, he tell you that Jaipur is at so and so elevation. See, he
okay,
might, you have to listen what he is communicating to you. So, ladies and gentlemen, we are right now on Jaipur location, which is at elevation of 1,000 meters, and currently our altitude is at 30,000 feet. Like this, he will communicate.
okay,
A lot of time we don't understand or listen because we are not used to those kind of communication. But he's whatever he is communicating, even to us, that is recorded into the flight recorder. So he has to follow the RT procedures.
okay,
Yesterday we because ATC is also listening, it is also getting recorded. So if there is some problem, I think they will see whether pilot is following the standard procedure, standard terminology, standard phraseology, all that procedure. So they will talk in that language only,
got it. Yeah.
right? So again, the same diagram. I mean, this will give you much better view. Okay, see here it is C, then the land starts from here. QFE, field elevation. See here, field elevation. Here, field elevation would be different. Again, field elevation different. Different. So depends. See here now, lake is there. Okay, so different is there. So as of now, don't worry about this because this is more from the civil aviation or from the when you're flying the actual aircraft and all the things. Very important. As of now, you just remember only one is QFE, the height on which the drone is flying as of now. Okay, I told you yesterday that how do we measure the wind speed? Okay, one is this is the device what we have which called is aerometer. It's a device that is used for finding the wind speed. Okay, it's analog as well as digital. Okay, like earlier people used to count. There was a mechanical anemometer which is available, which will tell you how much rotation per minute or per second it is doing, and then we'll tell you. So now these are digitally available. This is very, I think something around 300 rupees you will get this anemometer, and you will tell you the speed of the wind at that point in time flying. So this is helpful to measure uh, when we are flying our drone. So when we are actually trying to do our training, also we'll have this anemometer in our hand. We'll try to measure the speed at that point in time when we are flying the drone. Yeah. So at our location, we have installed the windsock also. So whenever we have a drone flying, we'll always install the windsock. So if you see windsock is nothing but there are five bands into it. So it starts with first, second, third, fourth, and fifth. So three red and two white bands are there. So if you see with respect to the position, like first red band is only horizontal, then it is 3 knots, okay, or 5.5 kilometers wind speed is there. So normally we call it as 3 knots. If first two, like red and white, is there, then it is 6 knots. First three, then it will be 9 knots. First four will be 12 knots, and all five in a horizontal position. That means 15 knots. That means wind is very powerful at this point in time. A light flexible cylinder cone mounted on a mast to show the direction. So it will show the direction also, what direction. So based on the direction the wind is flowing, and based on how much power the wind is there, it will have its shape made. So if it is completely horizontal, means it is the wind is flowing at 15 knots. The wind speed is there, or at 28 kilometers. That much high wind is blowing at that point. So during, if it is completely straight, you should try minimizing, avoid your drone flying, because it will impact your movement of your drones. Every time you have to control your drone, or there will be drift. Since right now all the GPS models are there, like if imagine your drone doesn't have all those sensors. So when you're flying, you do not have, you have to control it manually. Okay? Or even I can shut down the devices and put it in a manual mode. So that point in time, I have to correct my drone continuously, counteract. So whereas since GPS is there, it will always lock to that GPS position, and drone will be stable at it. But that point in time, the power it has to utilize to counteract the wind speed, where you will lose your battery or power from your battery unnecessarily. Okay, so different types of wind.
सर, आणि हे होतं माझ्यासोबत पण होतं. ज्यावेळेस विंड भरपूर असते ना त्यावेळेस बॅटरी बरीच खाल्ली जाते आणि बॅटरी बॅकअप इतका देत नाही. मी बघितलंय, हे झालंय
For
माझ्याबरोबर.
example, in a standard condition, like something around 9 knots, it's okay. Okay, but 12 or 15 knots is very high wind, high pressure wind. So what happens, when you are flying the drone in that, like in a standard ideal condition, your drone might be giving you 20 minutes power. In a 15 minutes knot, you may get it only 50%, because every time it is counter interacting with to compensate the wind pressure. So it will more throttle, it will give you more power to the propellers, it will try to compensate on its own. It has to do a lot of computational part and all that things. It has to go against the gravity as well as against the because wind will also push it down also sometimes, or may go haywire here and there. Okay, so every time it has to lock to that particular position. It has to counter itself with respect to the gravity as well as the wind. Okay,
Yes.
let's see now different types of winds. So gust or lull. Okay, so gust is a sudden increase in wind speed, often with a change in direction. All of a sudden, your wind direction will change, and it is just for a minute. All of a sudden, it's a local effect. It's because of the change in the pressure and all that things happens. Whereas lull is a period without waves or wind. Okay, it's a period without waves. I mean, all of a sudden everything will become calm. Okay, so gust, after a gust, you will suddenly there will be a very strong wind will flow for a minute, and all of a sudden everything will become silent or calm. Okay. Squall is again a sudden increase in wind speed, often with change in direction, lasting for 1 minute or more. Very large, maybe for a more period of time, more than a minute also. Can cover a wide area. Squall is really important to be predicted. Carelessness on the part of the squall can result in crash of the drone and henceforth. So that's the reason why we install the windsock, because wind speed is very small device to measure. Windsock can, it is at a particular height, somewhere around 12 feet we put the windsock, and it gives us the clear indication how. That's why you will see even today, though we have so much technology, we still rely on the windsock. Every airport, every aerodrome, you will see a windsock installed. Okay, because windsock will give you more better view of the direction of the wind as well as better understanding of your wind speed. Okay, at least you will get some better idea about it. You can't afford to ignore the wind speeds or the wind change in the wind speed or the direction also. Okay, gale and hurricanes. Well, hurricanes, see, it is how, when we talk about gale, we talk about windsock at 15 knots. Here we are talking gale at 33 knots. So means how fast the wind is flowing. So in gale or hurricane situation, you should never fly your drone. Hurricanes is almost double. See, 63 knots. That means four times the standard wind speed. Okay, 15 knots, what you see on windsock. Here, hurricane, you are talking about 63 knots. Okay, so these are the two conditions you should never fly your drone. Okay, so relation between the speed units, that's what we are talking about. So in aviation, generally speed should be measured in knots. That's why I was talking about knots. But ICAO specifies the standard to be measured in kilometers per hour. Okay, so 1 knot is 1.852 kilometers per hour, whereas 1 kilometer is 0.623 miles per hour. Like in normally, you are flying an aeroplane in British. So British actually have a tendency to follow their own units. So they will talk about miles per hour, whereas Americans are always using a very standard international standard units. So they will talk about kilometers per hour. Okay, so depending upon where you are flying your aircraft, you need to communicate in that unit over there. Okay? Like British are very fond of using or old unit of measurement for measuring the length. They measure the length in inches, whereas American uses meters and centimeters, kind of millimeter kind of this. So there is always a difference. If you see inch between the inches and the centimeter, there is a difference. Like one inch is like almost 2.54 centimeters. So that 0.54 difference is there. So American has a very standard units to measure the devices or things. They have different standards. Whereas British in old times they were using a different standards. So to overcome these differences, these ISI standards have come into the pictures, or ANSI standards, what we call it, where we measure the distance with respect to kilometers, or we measure the length with respect to millimeters or centimeters or meters. Okay. Similarly, earlier even this wind speed was measured with respect to the knots. Okay, but now what is 1 knot? 1 knot is 1.852 kilometers per hour. So if you're talking about 12, let's say 3 knots, so 3 knots is nothing but 1.852 multiplied by 3. Okay, so roughly around 5 point something could come. So now, as we talk about the weather, the wind, let's talk about the cloud, because cloud also plays an important role when we are flying very high. This will not be very much impactful for a drone as of now, because we are limited to our ceiling of 400 feet. So cloud is nothing but mass of a minute water droplet or a tiny crystal of ice formed by the condensation of the water vapor in a free air at a considerable elevation. As the clouds are formed at some height over the surface of the earth, they take various shapes. According to their height, expanse, density, and the transparency, the clouds are grouped under four types. So there are four types of clouds. One is cirrus clouds, cumulus clouds, stratus clouds, or nimbus clouds. So depending upon their location and their height and the type, based on the height, expanse, density, and transparency of the cloud, they are classified like cirrus, cumulus, stratus, and nimbus. So let's see one by one what are they. So when we talk about cirrus cloud, they are normally found at height of 8,000 to 12,000 meters. Okay, they are very thin and having a feathery appearance. They are always white in color. Whereas if you see cumulus, cumulus is between 4,000 to 7,000. So between cirrus, you can see a thick cloud also. Okay, they exist in a patches, can be scattered here and there, and cumulus would like a cotton. So if you see, how do you remember? Most important is their appearance. If it is like thin and feathery, it is cirrus. It is thick and like a what do you say, like a cotton wool, okay, kind of thing, thick. So then they will be called as cumulus. Okay. Whereas if you see the other one, stratus. Stratus is again they are they are in a very large portion. Okay, very covering large area. So that is a stratus cloud. Whereas nimbus is black and gray, and this is you normally see it during the rainy season and all the things. So all other three white colors you will see it regularly normally, but mostly the black gray color clouds you will see when there is a it is extremely dense and thick during the rainy season part. Okay, they do not have any particular shape. They will completely cover your area. There will be, you will not, there is nothing shape specific about it. It will completely engulf the area what you have. So nimbus cloud mostly happens during when it is about to rain or before the rain. You will see this type of cloud. Okay. So weather impact on US happen. So cloud base, let's say 9,000 feet distance to the cloud is 2,000 feet. So it will definitely impact your vision line of sight. Visibility less than 3 miles, we lost impact. Fog cloud perception, airframe loads, short circulating of electronic, we lost impact. So during, because this moisture will go inside the motor, moisture will go inside your flight control and all. So it is always advisable not to fly drones during this type of weather, like it is very foggy, cloudy, or you will see water vapors and all that. So even sometimes icing will also. Icing, you have seen, you must have heard a lot of time, air crash happening because of the icing on the wings. The sensors were blocked because of the icing. Similarly, you should not fly your drone in icing condition. Like for example, you don't fly most often the drone in like Kashmir or very cold locations and all the things, because that will sometimes will have moisture or icing inside the components, and it becomes very difficult to get the right inputs of the components and everything. So there was some competition recently in the Kashmir location, Ladakh location, where all these manufacturers, all our type certificate manufacturers, there was a competition where they you can take your drone over there and test out your drone. How does it behaves in those environments? Okay, so there was a competition couple of months back, and I think one of the type certification vendor was has won the competition for his drone. Was able to fly in that Ladakh region or high hilly region or high where you have cold weather kind of thing. Again, wind shear, loss of control, inability to return to home. Sometimes because of the pressure of the wind and all the things, you might lose the control of your drone, and you may have to, you know, you will have a mission failure because drone will not able to anticipate the RTH or RTL communication method, and it is not able to return back to its intended home location or a launch location. Okay, moderate or great turbulence, reduce mission duration. So a lot of time you will not get, as I said, as Pranay also said, whenever there is a huge wind and all things, you will normally not get as much as the endurance capacity wants. So duration will definitely will reduce. So when you are in normal condition, you are flying your drone for 20 minutes, you may fly it for only 10 minutes or 15 minutes, something like that. So these are the weather impacts on the UA operations. So as I was talking about VLOS, if you see from your position, you are here, okay, at the ground control station. So from you see how difficult, as I was talking about, like see 500 meters, okay, let's say this is 500 meters, so you can still see the drone properly. But as your distance double, okay, let's say 1,000 or 1 kilometer. Let's say I'm not talking about in miles, but I'm talking in kilometers. So this is 500, this is 1,000, so it is 1 kilometer. See, the drone starts becoming visibly very difficult. So for us, for a normal human, we can see somewhat up to 2 miles, okay, or not 2 miles, 2 kilometers, I would say, okay. But beyond 2 kilometer, it's very difficult to see the drone. Like especially like depends upon the size. Again, the size of the drone. Okay. For example, if this is a phantom drone, it's very difficult to do. But in that case, if you're using my agribot is much bigger than the phantom drone. So you may able to see at least much better at 2 kilometer range. Okay, but that may get difficult at 2.5 kilometer range. See, at 3 kilometer, it is almost very difficult, and 3.5, no possibility. So that's the zero visibility you have. You are not able to see. So actually, in a normal, as of now, in VLOS condition, we normally say it is always safer to see our drone up to 1,000, max to max 1,500 meters or 1.5 kilometer range. that you have to. It is judgmental again, okay, person to person, to area, location to location, based on the weather, and this is what we are talking with respect to the clear weather. Okay, you do not have. It's a very clear sunny day. That is where you are flying your drone. Okay, so cloud and fog both form when the water vapor condenses or freezes to form a tiny droplets or crystals in air. Cloud can form at many different altitudes, whereas the fog, now we are in a winter season, so you will see a lot of time the fog, right? Even on the ground, near to the valley or near to the river, you will see a lot of fog formation happening, and it becomes very difficult to see the things outside. Okay, so fog is defined as a cloud with its base at a very near the ground. Fog are caused by the cooling as the air cools because of the cooling earth. So that's why we see the fog in winter season. In summer, you don't see the fogs. Okay, and mostly the fog is seen even during the evening or at the morning time. Okay, when the temperature has dropped or the air has become cooler. Okay, so that time it becomes denser and drains into low areas such as the river valleys, where the thick fog accumulation where we occur. So that's why when we go to hill station,
सर
uh,
एक एक दिन मैं उड़ा रहा था ड्रोन। मुझे शॉट लेना था, सन का सनराइज हो रहा था
mm,
और क्लाउड मुझे मतलब ये थे, फॉग था।
fog होगा ग्राउंड पे।
हाँ, तो फिर मैंने फ्लाई किया। मैं ऐसा शॉट ले रहा था कि फॉग से बाहर आएगा ड्रोन और सन कैप्चर करेगा।
करेक्ट।
तो मैंने फॉग के अंदर कैमरा मतलब ड्रोन लिया, तो मुझे वॉर्निंग आहे की विजिबिलिटी लो आहे, तर तू वरती आहे. म्हणजे ड्रोन पण सांगतात आजकाल की बाबा विजिबिलिटी नाही आहे, सो यू हैव टू
करेक्ट करेक्ट। सो वो
मूव आउट.
सेंसर से पता चलता है उसको क्या है सीन। Accordingly, it will give you. See, every time if you see the recent transmitters, sorry, the receivers or transmitters, our remote control, they are very smart. So they will keep on. Even your, like for example, since there is a radar installed on my drones, it will give me the information of your terrain. So it will talk about terrain changing, obstacles available, all that information it will. So it will keep on sensing the area, and accordingly it will keep on. My remote control will tell me terrain close, obstacle close, you know what, or you are breaching geofencing boundary. All that information will be keep on coming to you, and you have to do the corrections accordingly.
येस सर.
Okay, icing. You see the icing picture? The freezing rain is a common ahead of the warm front in the winter. Serious icing occurs when the aircraft is flying near the top of the cold air, mass beneath or a deep layer of warm. Lot of accidents in aviation has happened because of the icing. Okay, the raindrops are much larger than the cloud droplets and therefore gives a very high rate of catch. In freezing temperature, they form a clear ice. So you can see on the wing tips, even on your propellers. Okay, you will see the icing happening on it, or even on the frame, uh, your body frame of your drone, you will see icing on it. So normally in aviation, the icing is very affecting the wings. If there is lot of icing on the wing, your wing will become heavier. The way the air behaves, that Bernoulli principle, what we saw, it will impact the airflow. It will impact the lift. It will impact the performance of your plane. The way in a normal condition your aircraft is flying, and when there is the icing, lot of time you will have a lot of performance issue on that particular plane. Like let's say you might require a 10 gallon in a normal condition. When the wings are in a icing condition, you may require more amount of fuel to counter out the performance issues because of the icing. So recently, I mean, there were some accidents because of the icing. So there was a norm which was released by ICAO that all the aircraft, irrespective of the manufacturer, whether it is a Boeing or Airbus, they should have a anti-icing uh, feature implemented on the wings. So it will temporarily it will have some kind of a heat, okay, generated on the wings, so that that ice will evaporate and it will convert into water and fall down. That's the anti-icing equipment they need to. Sometimes they manually, if the air, like let's say I have flown my aircraft at Kashmir, and it has the Kashmir airport standard, and I want to now take off from it. So before takeoff, the pilot, as a pilot, I will inspect manually, physically, whether my wing is having icing or not. So I will, if there is icing in it, if my aircraft is having a facility of anti-icing, then I will on the anti-icing. If it is not there, I will ask the local airport people to put a hot water on the wings so that all that icing will get removed from my aircraft. So they will spray a hot water on the wings, so, so all the icing will get removed or disappear from it. And then I will take off my aircraft. Okay. So as of now, our drone is not having, but future we may have this kind of challenges and this kind of things in drone also. Okay. So this is how the structural icing, and this is what I was talking about. So it will affect how lift will decrease, thrust will decrease. It will have stalling, stall could happen, icing built on the elevators. Drag will increase because you are increasing the size, increasing the shape of your wing. So lot of performance issues will come up on your aircraft. So this is with respect to the fixed wing aircraft under the drone category. You will see that your drone or a fixed wing drone, you should have icing feature enabled on that, like predator drones, right? Because they are flying at very high altitude, and uh, you don't know where you need to, like we are, right now Indian government has taken predator drones for monitoring Ladakh or Arunachal Pradesh kind of locations which are very cold and very hilly area, high terrain areas kind of thing. So there you might require icing to be installed on those predator drones. Okay. One other thing, this with respect to the aviation lightning, lightning causes thunder, a sound from a shock wave which develops as a gases in vicinity of the discharge experience a sudden increase of pressure. Lightning occurs commonly during the thunderstorm, as well as types of energy weather system, but volcanic lightning can also occur during the volcanic eruption. Yesterday we talked about one of the example, a person flying a Boeing aeroplane with four engines over the Indonesia, and there was a volcanic eruption. At point in time, there was a lightning also happening because those sulfur particles which was there, and the ash, the volcanic ash was there in the air, and because of the change in the uh, temperature and all the things, so the lightning was happening. The volcanic ash was also in the air, and all. This was causing a lot of visibility issues, malfunctioning of the instruments or the sensors. A lot of challenge they faced. Their engines suddenly stopped running, and all of a sudden, they were with no engines. All four engines got dead, and pilot has to manually figure it out how to land safely. Okay, wind shear is sometimes to refer as a wind gradient or difference in the wind speed over a relatively short distance in atmosphere. So atmospheric wind shear is normally described as either vertical or horizontal. All of a sudden there will be a vertical wind, or it will be all of a sudden a horizontal wind could be also. So vertical wind shear is change in the wind speed or a direction with change in altitude. Whereas horizontal wind shear is change in wind speed with change in the lateral position. Okay, that means from one position, A position to it will one from A position it will go to B position. Whereas vertical it may be change in altitude. You can suddenly your drone may go up, suddenly your drone may come down. Okay, so this normally wind shear effects. I mean, drone is not so much because you are not flying very high, but this wind shear is very much important when you are flying a aircraft, a fixed wing drone, because there you are flying the drone at very high, very high altitude and all the things. So that time your vertical movement was so possibility, because of especially because of the vertical wind shear, possibility of your drone getting, I mean the fixed wing getting stalled. Stalled means you will suddenly lose your control on your drone, and suddenly your drone will drop like a stone. You will not have a chance to recover also, to get recovery from that particular position. I mean, you really need a lot of practice. From a stall condition, any aircraft from a stall condition to recover, you need to be an exceptional pilot. Okay, it's a test of a piloting skills to recover the recover the aircraft from a stall condition. Okay, it's very rare situation, I would say. You will not have a time, because the moment you get stalled from a stall position to coming to normal position, you will not have a time, because it will not have time. You will drop like a rock on the ground. That's why you will see whenever the aeroplane stalls, no aircrafts have what do you call that, recovered. They always have a crash most of the time. One or two conditions, depending upon the situation and depending upon where you are, how much distance you had, you are able to, or you maybe see there are different stall conditions or different stall positions. Some stall positions are very just initial or basic from where you can recover, but at extreme stall condition you cannot recover. You will, how better you might be there, better pilot you cannot recover it from, because you lose the complete control of the aircraft, and nothing, whatever you radar, you apply whatever elevator, nothing will work on that, because it is beyond your control, beyond the control. So wind shear, we talk about vertical and horizontal. So that's how visually it is described. Vertically is change in the altitude, whereas horizontal is nothing but a lateral shift in the position. Turbulence is a sudden violent shift in airflow caused because of windstorm or jet streams, object near the plane, particularly mountain range. So when we are, near the terrain, so in our drones, we have a terrain radar. So it will always give you the telling that you are near to the, or your height is changing. Terrain detected. It will continuously give you the beep. Even in the aircraft, when you're, let's say you are flying somewhere here below near the hilly area, and as you go further, it will tell terrain detected. A lot of time, even those wherever there is aircraft crashes with respect to the mountain, you will hear, if you hear the flight recorder voice, you will hear that beep continuously beeping into the cockpit. Terrain detected. But if pilot doesn't have a time, he all of a sudden he will see that there is a hill in front of you, and he will try to give the throttle. But then that marginally difference is there. Either his base or his tail will hit the terrain, and they will crash. Unless he has enough time to correct himself or do something, unless it's not a lot of time we see in Hollywood movies, uh, the pilot or the James Bond were able to give the throttle, fly the aeroplane in such a way that he recovers from crashing or anything like that. So you will see a lot of times this thing happening in a movies, but in real scenario, this is very difficult situation. So there has to be a threshold defined at what distance the terrain has to be detected. So as per the standard, whatever it is defined, it is always set into that standard. But a lot of time, because of the human error or human people, for not able to respond, we are sometimes we get into panic situation. We do not know at that point in time what we need to do. We are judgmental at that point in time, how and what. So sometimes we do something wrong steps, like even when we are driving, sometimes why does the accident happens? Because what we are supposed to do, we do not have a time to react, and that's why the accident happens. If we have a time, or we are able to correct ourselves, we can do those corrections. But if we do not have time, definitely the accident would happen. So same thing goes for flying the aircraft also. Light turbulence momentary caused because of a slight change in altitude or attitude at the slight bumpiness. Occupant of the airplane may feel that sometimes when we are flying, where there is a turbulence, we are encountering the turbulence. People are requested to be on their seat and wear the safety belt. Like that announcement is then because of this turbulence. If we are encountering sometimes the turbulence when we are flying at 30,000 feet or something like that. Okay. So light, moderate, and severe. So what is the difference when we are, how much difference? Like you will see almost bumping. You know, your aircraft will keep on going up and down, and pilots are trying to compensate it by, not actually, pilot is not doing anything, but pilot is just monitoring it. It's the computer, the pilot, autopilot will always try to, it will keep on doing it, controlling on its own things. If it is beyond the control of the autopilot, then only pilot will take a decision to put it in a manual mode. Even in whatever the severe condition also of a turbulence, pilot is still not authorized to change from autopilot to manual mode until and unless it is very very, because those actions will be asked, why did you move from autopilot to manual? That scenario, your action needs to be justified. So they are not allowed, even in a severe condition, uh, aircraft to be moved from autopilot to manual mode. Okay. So with that, we complete our weather and meteorology session. Any questions you have to discuss?
No, sir.
No, Mangesh. Yeah.
So we'll move out to the next topic.
Yes, yes.
So drone equipment maintenance, we have forgot to bring my book.